Hello everyone, welcome back. So this is just an on-demand video lecture. One student asked me, sir, I cannot understand the global wind circulation from textbook. Just requested me to analyze this topic and to make it understand. So I'll just briefly explain you how the global wind circulation happens. So basically what we call wind, that is air in movement, that is called wind. And before understanding or before getting into the lecture, we must understand basically that the question is global wind circulation or atmospheric wind circulation, and that depends on atmospheric pressure, how the pressure varies from one place to another, and what is the concept behind that, right? So before going to explain these things, I just want to highlight different terminology you have to understand. So what is atmosphere? So there are different four spheres. Our earth consists of four spheres, like lithosphere, the solid part, that is the ground, and the atmosphere, that is the gaseous layer covering this. Suppose this is our earth, and surrounding to this earth different gaseous layers are present, and it extends somewhere like 1600 kilometer altitude from this earth surface. So that is composed of different gases in different proportion. If we'll go on increasing the altitude, that gaseous composition changes. So this is basically the atmosphere. Then hydrosphere, that 3/4 part of our earth is covered with water, and that is life, and that is called hydrosphere. Then biosphere consists of different living organisms, that may be microflora, macroflora, microfauna and macrofauna, all the living organisms present in earth, that is coming under biosphere. So among all these four spheres, atmosphere is one sphere which is covering or surrounding to our all other spheres. Okay, atmosphere. So atmosphere consists of different gases, as I was mentioning, and this atmosphere is based on its altitude. It is divided or differentiated into different layers. Okay, so that is also that is, first layer is troposphere, okay, then stratosphere, then mesosphere, then thermosphere, then exosphere. These are different strata or layers. If we'll go from lower altitude to higher altitude, they are classified into different or grouped into different strata. Okay, first is troposphere, the lowest strata, troposphere, then stratosphere, then mesosphere, then thermosphere, then exosphere. Okay, so all these layers have significance from our survival point of view, from their importance point of view. They are having certain significance. Like if we'll say about troposphere, that is the lowest layer. So in troposphere, the gaseous composition is thick and it is uniform, or more or less whatever gases needed for survival of human being, like oxygen, that is in optimum quantity, that is around 20-21%, and about nitrogen, that is 78%, carbon dioxide right now it is 415 ppm or 0.004%. Okay, so that is kind of uniform composition you can find for what is important for survival, and all the weather activity, all the weather phenomena, that is happening in troposphere. I'm coming to your lecture. The global wind circulation will discuss different cells like Walker cell, Ferrel cell and all, then Hadley cell and all, and how the easterlies and westerlies happen. We will discuss later on. You just need to understand some points. Then coming to stratosphere. Okay, so stratosphere, how it is significant from our survival point of view. Stratosphere, the ozone layer, that is O3, the ozone layer that is found in stratosphere, which filters the UV radiation. See, when the solar radiation is coming from outside, it mainly consists of cosmic wave or cosmic radiation. Then and there are different electromagnetic wavelengths found in solar radiation. From that, what is important for us, that is the visible radiation, that is 400 to 700 nanometer. Okay, so before 400 nanometer, that is called the UV radiation. Okay, so somewhere 100 to 150 nanometer to 400 nanometer, that is called UV radiation, and that is harmful for us, for all the living organisms. Okay, so this ozone layer, it screens out that harmful UV radiation. Okay, so that is how ozone layer is significant, and for ozone layer, as it is present in stratosphere is helpful for us. Then mesosphere, thermosphere and exosphere. So these are having less significance. If we'll talk about mesosphere and thermosphere, in between this mesosphere and thermosphere, or at the lower layer of thermosphere, there is a layer that is called ionosphere. Okay, ionosphere. So all the communication we are doing, like radio communication, then TV signal communication and satellite communication, mostly happens through the ionosphere. So all these layers are having significance. So how the air circulation or wind circulation happens here? So there is, if we'll go on increasing the altitude, the temperature decreases. Okay, there is one is called, the phenomena is called lapse rate. Actually, lapse rate, this is also important from exam point of view or competitive point of view. Lapse rate. So what is lapse rate? If we'll go on increasing the altitude, the temperature decreases. Temperature decreases. In troposphere, if we'll go on increasing the altitude, the temperature decreases. Okay, up to what? Up to tropopause. That is a layer between troposphere and stratosphere. Up to tropopause, the temperature will decrease if we will go on increasing the altitude. Okay, and there is a common value, that is 3.5 degree Fahrenheit per 1000 feet, or 6.5 degrees Celsius per 1 kilometer. Okay, so if you can say 1 degree Celsius per 165 meter. Okay, so these are called normal lapse rate. Normal lapse rate. Okay, so what is lapse rate? The decrease in temperature if we'll go on increasing the altitude, or if we'll go on increasing the height of the atmosphere, then the temperature decreases. That is called lapse rate, and the values are 3.5 degree Fahrenheit per 1000 feet, or 6.5 degrees Celsius per kilometer, or 1 degree Celsius per 165 meter. Acha. Now what is tropopause? That is a layer found between troposphere and stratosphere, where there is no increase in temperature or decrease in temperature happen. Okay, that is a thermostatic layer, right? Like that, in stratosphere, the second layer, above troposphere, there is stratosphere. In stratosphere, what happens? If we go on increasing the altitude, the temperature increases in stratosphere. Then in mesosphere, again reverse, it decreases. Then in thermosphere, again it increases. Okay, like that it happens. So temperature, it decreases in troposphere, then increases in stratosphere, then mesosphere, it also decreases. In thermosphere, that is increases. And between these two layers, troposphere, stratosphere, that is tropopause, where no change of temperature happens. Okay, again stratosphere and mesosphere, that is stratopause, where there is no temperature change. Again mesosphere and thermosphere, there is a, between those two layers, mesopause, there is no temperature change happens. Okay, so this is how lapse rate follows in the atmosphere. This is how temperature variation happens. Okay, so this is about brief idea about atmosphere and its layers. Now coming to our global wind circulation. Okay, so before understanding the global wind circulation, we have to understand how our earth pressure belt varies. Okay, so coming to pressure belt, let me just so this is our earth. So all of you clear about altitude, latitude and longitude? What is altitude? Altitude means height from mean sea level, or height from ground, because ground is undulating, so we are considering the mean sea level. So height from mean sea level, that is called altitude. Higher altitude means temperature will decrease in troposphere, as I was mentioning. And what is latitude? Latitude means, we know equator, that is dividing our earth into two equal sphere, northern sphere and southern sphere. So this is, let's say this is the equator. Okay, that means 0 degree, right? If we'll go to the north, towards north and south, then that is called latitude. Okay, longitude, like that, longitude means the perpendicular division of the earth. Okay, 0 degree longitude, that moves along London, okay, along the city London. Then if we'll go east, then that is called east longitude. Then if we'll go west, then that is called west longitude from the prime meridian. This is called prime meridian that moves along London city. Okay, so these lines are these perpendicular lines, these are called longitude, and these horizontal lines, they are called latitude. Clear? Altitude, you must be clear about altitude, latitude and longitude. Okay, so if I'll say what is the two-dimensional location of a particular place, you must answer in latitude and longitude form. So let's say what is the north latitude, what is the south latitude, then what is the east longitude or west longitude. Clear? Then if I say three-dimensional location of a point, okay, along with latitude and longitude, you have to answer what is the altitude or what is the height or what is the depth that particular object or location is at. Okay, so this is about latitude, longitude and altitude. Let's coming to our topic, that is the pressure distribution and wind circulation. Pressure distribution and wind circulation. Let me draw that the earth. Okay, so my drawing is quite bad. Okay, fine. So this is how our earth looks like. Okay, you assume this. Then this is our equatorial line, and that is 0 degree, or it is called equator. Okay, fine. Next, so this is the subtropic belt, or this is 30 degree north latitude, 30 degree south latitude. Okay, so these are called subtropic. Okay, this is tropical line, or these are called tropical Cancer and Capricorn. Okay, then another important 60 degree north, 60 degree south. From pressure point of view, this is called tropical, this is subtropical, this is temperate, and this is polar. 90 degree south, 90 degree north. So this is how our pressure belt varies. So this is tropical belt, this is subtropical belt, this is temperate belt, this is polar area. Clear? This is, so 0 degree and 5 plus minus or 5 north, 5 south, that is tropical. Okay, or equatorial, tropical, equatorial. Then 30 plus minus 5, 35 or 25, that is, or 30 to 35, that is called subtropical belt. Then temperate belt, 60 to 65, temperate belt. Then this is polar. Now, so what will be the pressure in this equatorial line, whether it will be higher or lower? As we know, here the direct solar radiation falls in equatorial region. Why the equatorial region there is higher temperature? Okay, and if we'll go on increasing, like suppose if we'll go from India to China, then Russia, then beyond that, then there will be polar region. There almost throughout the weather there is lower temperature. Why? Because of solar radiation, it is not falling directly, it is falling with certain angle, and the angle is more acute towards if we'll go on increasing the latitude. Okay, so here slanting solar radiation is falling on the equator. Okay, and here direct solar radiation or perpendicular solar radiation falling on equatorial region, and in polar region, that is, the radiation is falling not directly. Okay, so here as more solar radiation insolation in equator, there is low pressure. So what will happen if here, let's say I am increasing the temperature, what will happen? The air will expand. As the temperature is increased, the air will expand, so it will move upward. So if the air from here at this place moving upward or moving surrounding towards its periphery, then at this particular point, what will happen to the pressure? Pressure will decrease. Okay, like that, as in equatorial line, the temperature is higher because of direct solar radiation. The air moves to the higher altitude. Okay, it will expand and it will move, okay, to the higher altitude. So the there is creation of low pressure belt in the equator. So equatorial region is having low pressure belt. Okay, low pressure is created in the equator. That is called, that low pressure belt is also called doldrum. Okay, so air in this region that will move upward. Okay, what happens to that upward air? That will, as it is a low pressure belt, what will happen? Here there is low pressure is created. Okay, air, remember, air or wind that always moves from high pressure area to low pressure area. Okay, if you do not have anything to give someone, you cannot give anything. Okay, but if you find a beggar, you always wanted to give them something. So you have something, you are higher, at higher position. Like that, water moves from higher potential to lower potential. Like that, air moves from higher pressure to lower pressure. So here, as we discussed, in equatorial region there is low pressure belt is created, that is called doldrum. So from 30 degree or from north and south, air will move towards the equator. From north and south, air will move towards the equator like this. Okay, so these are called easterlies wind. These are called easterlies. Okay, these winds, those moves from which, these are subtropical region. Okay, 30 degree north subtropical and 30 south subtropical region. So from subtropical region, wind will move towards equatorial region, and those are called easterlies. Okay, suppose this, you can say northeast easterly. Wind always named after from which direction is wind blowing, not towards where wind is blowing. Okay, so these are called, this is called northeast easterlies and this is called southeast easterlies. Now you can ask one question, sir, it should move perpendicular, like from subtropical high to equator, it should move like this perpendicularly. Why it is moving like northeast and southeast direction? Why it is not moving like from south to straight center or north to straight center? See, there is a phenomena called Coriolis force. Earth is rotating around its own axis. Okay, so due to that rotation, these subtropical wind or these winds that is blowing from subtropical region to equatorial region or equatorial calm or doldrum, from subtropical high. So here it is high pressure belt. Remember, subtropical region, this is high pressure belt, doldrum, it is low pressure belt, polar, this is high pressure belt, and temperate, this is low pressure belt. Okay, clear? This is low, this is high, this is low, this is high. Okay, and how they are created? Here low pressure in equator, that is created due to direct solar radiation. In polar, why there is high pressure belt? Because no solar radiation can reach there, the air is thick. Okay, and there is temperature is low, so temperature and pressure is inversely related. Okay, so as the temperature is low, the pressure is high there. Okay, but remember, acha, where we are, acha, so these are northeast, these are called trade wind. Okay, northeast trade wind and southeast trade wind. And what is the direction? From northeast to equator and from southeast to equator. Okay, and this is called, this cell, see here this cell moves like this. Okay, the lower layer, that is the lower air that is moving from subtropical high to equatorial low, high to low, lower layer, but in upper atmosphere that is moving from low pressure to high pressure, because that air already moved to upper atmosphere, that will move to the subtropical region. Okay, so there is a circulation, and this circulation, lower layer moving from high to low and upper layer moving from low to high, this is called Hadley cell. Hadley cell. This is called Hadley cell. Acha. Now again here is low pressure, this temperate region. Here there is another low pressure belt. Sorry, this is the temperate region. Okay, here is another low pressure belt. Because here is high, so this temperate region is low pressure belt, right? So as here there is low pressure belt, see this is Hadley cell, right? This is Hadley, this is Hadley. Okay, next what will happen? As this is high pressure and this is low pressure, this is low pressure, this is high pressure. So from where to where air will move? Air will move from this high pressure belt to this low pressure belt. Okay, right? So this is, so you got the direction. This direction is actually due to the wind, the rotation of the earth, not due to any force. Okay, this is it is also called Ferrel law. Remember Ferrel law, and this Ferrel law proposed the movement of wind not perpendicularly in angle, or it is from direction of northeast or southeast towards the equator. So that Ferrel law is based on Coriolis force. What is Coriolis force? Due to rotation of the earth, wind direction changes, global wind direction changes. Okay, remember this points. Okay, now the wind from subtropical high, it will move towards temperate low. Remember, the wind from subtropical high, it will move towards temperate low in lower atmosphere, but in higher atmosphere again the reverse. Okay, so this belt, this wind circulation in lower atmosphere, it moves towards this, and in higher atmosphere moves from temperate low to subtropical high, and this is called Ferrel cell. What is Hadley cell? Remember what is Hadley cell? The wind movement from subtropical high to equator in lower atmosphere, and from equator to subtropical high at higher atmosphere. Okay, and what is Ferrel cell? The wind movement from subtropical high to temperate low at lower atmosphere, and temperate low to subtropical high at higher atmosphere. That is called Ferrel cell. Another cell is there, that is called polar cell. Polar cell, where it is located? It is located from polar region to temperate low. Okay, so how the wind will move? It will move like this. Okay, so the wind moves from in the lower atmosphere from polar region, because polar region is having higher pressure, to low pressure temperate zone. Okay, and in upper atmosphere low pressure temperate zone to polar region. Okay, so wind will move like this, polar region to low pressure temperate zone at lower atmosphere, and low pressure temperate zone to polar region at higher atmosphere. This is called polar cell. Okay, polar cell. So there are three different cells that regulate the global wind circulation based on pressure difference. Okay, one is Hadley cell, that is the movement of air from subtropical high to equator at lower atmosphere, and equator to subtropical high at higher atmosphere. That is Hadley cell. Then Ferrel cell, that is subtropical high to temperate low at lower atmosphere, and temperate low to subtropical high at higher atmosphere. Then polar cell, polar region to temperate low at lower atmosphere, and temperate low to polar at higher atmosphere. And you got the wind direction, how the wind direction happens. Then another term is that is called horse latitude. So what happens? So winds from this subtropical high moves towards both equator and temperate low, equatorial low and temperate low from subtropical high. Remember, from subtropical high winds move at the lower atmosphere or lower altitude. Wind moves from subtropical high to equatorial low and temperate low. Okay, but in upper atmosphere, again that wind moves from equatorial low to subtropical high and temperate low to subtropical high, and those both the winds that is coming in upper atmosphere that collide at the subtropical high. So there the wind movement is very less. Okay, wind movement is very less. So what happened during the earlier period when there is the commerce was taking place through boats, and those boats which are having clothes for selling of the boat. Okay, so what happens that and the movement of those boats depends on wind. Okay, solely, and there was no motorized boats at that period. Okay, so what happened when those boats they conducted the commerce activity, and when they reach this subtropical high in both north and south, there is very less wind movement in those area. Okay, so basically they had to drop their horses, because at that time they trade horses. Okay, so they had to drop the horses to the ocean at that particular region to move their boat. If the boat is lighter, then it will move easily. So they had to drop their horses in those latitude. That's why they are called horse latitude. This which region is called horse latitude? This subtropical high region, that is 30 to 35 degree south and north. These are called horse latitude. Okay, so I think you have got an overall idea about the pressure distribution and how global wind circulation happens. So what we had discussed in this lecture, we had discussed about atmosphere, what are the layers of atmosphere, what are the significance, then globally how pressure distribution is there, and how the wind movement happens, and what are the factors affecting wind movement, and different cells, wind circulation cells. Okay, I hope you like this lecture, and I think I am able to make you clear about different wind circulation, global wind circulation. If you have still any doubt, you can ask me in the comment, and if you want any further lecture in any other concept, then you can tell me in the comment section. See you in the next lecture. Till then, have a great day.